I remember something like 6 years old, and I told the people that I want to be a professor. I'm not sure I knew what professor really meant, but you hear about things, and I want to be a professor. I grew up very poor. My family was very, very poor. The schools I went was very poor, so I didn't have so-called role models any. But nonetheless, I was sort of naturally got interested in, I think it's a lot of other human beings do, that origin of time, where's how time began, and about the universe and such. Still working on it. I don't think I have answered those questions. I really didn't have that kind of mentor when I was younger. However, I did have the people kind of indirectly, they didn't mentor me, but I get to know them. One person, he's arguably probably the best physicist in the history of South Korea. His name is Ben Lee. When I was a freshman in college, Ben Lee came to Seoul National University. He gave a colloquium, and that itself was just cool. So we were all kind of mesmerized about it. And then I had the pleasure of meeting Maurice Goldhaber. He is, I will say, another legend in our field. And Maurice Goldhaber is the first person who experimentally determined how long protons can live. I was very much got into this question about protons. Does the protons ever die? And then that question is the one actually led to my current research about last 30 years. Neutrinos generally were nuisance background for proton decay search. But then we couldn't find the proton decay, so therefore we changed our attention to neutrinos. So one of the experiments I was heavily involved in, the Super Kamiokande, K2K, and the T2K, those are the main experiments. One of the biggest things was that we discovered neutrinos oscillate. There are 3 types of neutrinos: electron neutrino, muon neutrino, tau neutrino. One of those interviews I had with the LA Times, I used the knowledge of ice cream for neutrino flavors. Let's say your muon neutrino is chocolate ice cream, and then you make a chocolate ice cream, you throw it across the country, and then when you receive the other side, it turns into vanilla ice cream. This actually happens in neutrinos. We do many experiments, we make breakthroughs, we understand more things. However, I consider this is that we are, building little sand towers. Towers get bigger and bigger, but still, it's a long way to go. Physical sports, I offered in 2003. I know I will be studying and teaching physics all my life, but I have interest in arts and sports. And then I realized that everything what we do in the sports is essentially classical mechanics. What's the difference between four-seam fastball and two-seam fastball and changeup? Four-seam fastball is not only stays more straight, it actually goes faster. Now, four-seam fastball thrown with an underspin, it experiences something called a magnetic force, which lifts the ball from below to upward. And so magnetic force is compensating the gravity large extent. That's why ball does not drop as much as other balls. As you are better, when you see a 100 miles an hour four-seam fastball, it appears to you ball is almost rising. But that's an optical illusion because the pitcher mound is higher up, and then ball doesn't drop as much as other balls. As a lecturer, as a professor, the way I see it is that no matter what topic I teach, as you walk in the classroom, essentially you have to consider yourself as a performer. So you have to know the level of students and then how to get their attention. But most importantly, you need to able to convey the enthusiasm. And then students can see that. That is like pleasure. That's the really pleasure of his life as being a professor here. And that's the pure joy of being a professor. And in fact, it's joy of my life.